6.2b. For this lesson, we're going to describe end behavior of polynomials and then graph them as well. All right, so when we start talking about end behavior, basically what we're trying to say is what is happening to that graph once we get out of that coordinate plane that we see. Okay, so let's look at f of x equals x. That is linear. So what we're going to do is we're just going to do a rough sketch. So if you think about it, y equals mx plus b. In this case, you're getting a slope of 1 and a y-intercept of 0. So we just got a positive sloped line. And now for end behavior, we're trying to say what's happening when we go beyond that. Okay, how is it ending? Now, anytime we do this, the way we say this, as x approaches infinity, f of x, or the function, is doing what? And then as x approaches negative infinity, f of x, or the function, is doing what? So now when we think about this, as x approaches infinity, x is referring to our x-axis, so our axis that goes left to right. So if I say as x goes to infinity, it's saying as I'm going right on the graph, what is that function doing? So in this case, as we go right, it is going up. Okay, now up and to the right is positive, down and to the left is negative. So in this case, as we go right, or as x approaches infinity, f of x is also approaching positive infinity. Now, if we look at it as x goes to negative infinity, so as we go left on the graph, it is going down, and when we go down, that is approaching negative infinity. Okay, so as x approaches infinity, f of x is approaching positive infinity. As x approaches negative infinity, f of x is approaching negative infinity as well. All right, so looking at f of x equals negative x, that's just a negative slope line. So in this case, we'll do as x approaches positive infinity. So as we go right, the graph is going down, which is negative infinity. And as x approaches negative infinity, or as we go left to the graph, the function is going up. So that is going to positive infinity. All right, so those are linear. Now f of x equals x squared. Those are parabolas, our quadratic functions. Okay, positive a value there. So we got a parabola that opens up. Now, again, as x approaches infinity, so as we are going right, the graph is going up, so we are approaching positive infinity. As we go left, or as x approaches negative infinity, it is going down to, oh, sorry, not down, thinking linear. We're going up, so we get positive infinity. All right. Now, let's go ahead, let's do negative x squared. So that's a parabola that is opening downwards. So as x approaches infinity, as we go right, the graph is going down. So we are approaching, the function is approaching negative infinity. And as x approaches negative infinity, or as we go left, it is also going down, which is approaching negative infinity again. So what you're going to notice is when it's linear, f of x approaches the opposites. If x squared, so parabolas or quadratics, they're going in the same direction. So your f of x approaches the same positive or negative infinity depending on which way it opens. All right, so x cubed. This is where we're going to start getting into functions beyond linear and quadratic. So here we have a cubic function. Okay, so our degree is 3. Now, when we are graphing these, the end behavior is exactly the same as linear. Now, when we graph these, it's a little bit different, as there's going to be some type of inflection point. So it's not a straight line. We get where it changes directions a little bit. That is called an inflection point. Okay, but the end behavior is similar to a linear. Okay, positive a value again. So think of it just like a positive slope line. So in this case, as x approaches infinity, f of x is approaching positive infinity. As x approaches negative infinity, f of x is approaching negative infinity. Okay, so again, that's the same exact end behavior as a linear that has a positive leading coefficient. All right, so negative x cubed, when I do this, I think of it just as a negative slope line. Okay, but now in this case, you're going to have that inflection point, but the end behavior is the same as a linear function with a negative a value. Okay, so in this case, as x approaches positive infinity, f of x is approaching negative infinity. As x approaches negative infinity, f of x is approaching positive infinity. Okay. So x to the fourth are quartic functions. These have the same end behavior as quadratics. Now, in these cases, we're just going to have more turning points throughout the function. Okay, but the end behavior is the same as a quadratic. So in this case, as x approaches positive infinity, f of x is approaching negative or positive infinity. As x approaches negative infinity, f of x is approaching positive infinity. Okay, so when it comes to these quartic functions, again, like I said, the end behavior is the same as a quadratic. If that a value or the leading coefficient right here, what would be in front of that leading term, okay, if it's positive, it opens up. If it's negative, it opens down. All right, so negative x to the fourth. So think of it just like a parabola or a quadratic function with that negative leading coefficient. Okay, just now we have those turning points. As x approaches positive infinity, f of x is approaching negative infinity. As x approaches negative infinity, f of x is approaching negative infinity. Okay. Now, so when it comes down to this, all that really matters is what the leading coefficient is and the degree of the function. So let's look at some actual functions here. Okay, so we got 3x squared minus 2x cubed plus 4x. Now, anytime you're doing this, it's going to be easier if we write it in standard form. So again, the highest degree will go first, so that negative 2x cubed plus 3x squared plus 4x. Once you have it in standard form, the only thing we have to worry about is that leading term. Okay, we got a negative a value, and it's a cubic function. Okay, again, cubic function, treat it like it's linear. Okay, so since it's a negative coefficient, then it's like we have a negative slope line, but now we just have that inflection point. But the end behavior is what I'm concentrating on here. So as x approaches positive infinity, f of x is approaching negative infinity. As x approaches negative infinity, f of x is approaching positive infinity. Okay. So again, the only thing that you need to concentrate on is that leading term when it's in standard form. All right, so for this one, not in standard form, so let's write it in standard form. Ooh, plus 7x squared minus 3. And again, we only need to concentrate on this. Okay, so it's an odd degree, meaning the end behavior will go in opposite directions. Opposite directions with a positive slope. Okay, so the big thing is that the end behavior will go like that. And since it's a fifth degree, it's going to have some type of turning points in there, but I'm not worried about that right now. All I'm looking at is the end behavior. So in this case, as x approaches positive infinity, f of x is approaching positive infinity. And as x approaches negative infinity, f of x is also approaching negative infinity. Okay, so when it comes down to it, just a quick sketch, and then you are looking at the end behavior of that graph. So when we look here, we are in standard form. We have a even degree, so therefore the end behavior goes in the same direction. Now, since it is negative, it will open down. Okay, so again, it's fourth degree, so there'll be some type of turning points in there. Again, this is just a rough sketch, but it gives us the idea that as x approaches positive infinity, f of x is approaching negative infinity. And as x approaches negative infinity, f of x is also approaching negative infinity. All right, so last one for end behavior, 4x squared minus 5x plus 2, that is in standard form. It is a parabola that will be opening up, okay, due to an even degree and a positive leading coefficient. So as x approaches positive infinity, f of x is approaching positive infinity. As x approaches negative infinity, f of x is approaching positive infinity as well. Okay. So the big things to take from this: even degree, end behavior, goes the same direction. Odd degree, opposite direction. Okay, then from there you got to look at that leading coefficient. If it's a positive, then you got to think of it like a positive slope line, or if it's an even degree, then it's opening upwards. Okay, negative for even degrees, both are going down. Odd degree, it's like a negative sloped line. All right, so now let's look at actually graphing them. We aren't technically graphing, we are sketching. And the way we're going to sketch is we're going to look at the end behavior, and then we're going to plot some specific points. Okay, so let's look at the end behavior here. We got x cubed. It is in standard form already. So again, we look at that leading term. It's an odd degree function, so end behavior will go in opposite directions. A positive a value. So therefore, our end behavior, if you think about it, positive, so think of it like a positive slope line. As x approaches infinity, f of x is approaching positive infinity. As x approaches negative infinity, f of x is approaching negative infinity. So when we graph these, we need to make sure we end there and end there. In between is what we're going to figure out here. Okay, and the way we do that, we're just going to do an xy chart. Okay, and the values we're going to do for x, -2, -1, 0, 1, and 2. Okay, so when doing this now, since we know how to do synthetic substitution, we can use that, or we can use direct substitution. From teaching this for 4 years, you guys will have an easier time or have a more accurate answer if you use your synthetic substitution. Okay, so again, when we do this synthetic substitution, we're going to do the x value. So if I'm doing -2, that's the value that's going to be on the outside. And we got x cubed, so there should be 4 terms in our box, which will be 1, 2, -1, and 3. And again, we drop down that first term, multiply, add, up and down. Multiply times that -2, add up and down. Multiply, add. And that last one will be the value for f of -2. Okay, so now with these, you're basically going to have the same setup. It's just we're going to have -1, 1, 2, -1, 3. And you're going to do it with 0, with 1, and then finally 2. And you got to evaluate at 2. So we'll walk through this on this one. Bring it down, 1. Okay, 1 times -1, we get -1. Add, multiply, add, multiply, add. Okay, so we get 5. Then when we plug in 0, and still bring it down, we get 1. 1 times 0 is 0. 2 plus 0 is 2. 2 times 0 is 0. -1, -1, 0, 3. So f of 0 is equal to 3. Okay, doing 1. Bring it down. 1 times 1. Add, multiply, add, multiply, add. And finally for 2, multiply, add, multiply, add, multiply, add. Okay, then from there, what we have are some points. Okay, this is just a point on the graph, negative 2, 5, negative 1, 5, 0, 3, 1, 5, and then 2, 17. They're ordered pairs. So negative 2, 5. Going to plot those points, negative 1, 5, 0, 3, 1, 5, and then 2, 17. We just know that's going to be up here somewhere. Okay, so now since I know my end behavior, I will be down here, because we know as x approaches negative infinity, f of x approaching negative infinity, and what we're going to do is we're just going to flow through those points. Now, do not play connect the dots. There is no graph you will ever do that does that. Okay, this is just an indicator that it's a turning point. Okay, so we'll turn, and we need to go up to 17. Okay. So again, there is a rough sketch of our graph. Okay, now when I correct these, all I look for is the end behavior. So I'm looking that you have as x approaches negative infinity, you're going down, and as x approaches positive infinity, you're going up. Okay, and again, do not play connect the dots. You need to make sure that this graph is flowing through those points. All right, so another one, x to the 4th. So we have an even degree that is positive. So again, think of it like a parabola. Positive a value, that's an even degree function. They are both going up, so we are approaching positive infinity no matter which way we go. Okay, again, xy chart, negative 2, negative 1, 0, 1, and 2. So when we do this, you don't need to use that synthetic substitution, but again, I highly recommend it. That's the only way, I shouldn't say the only way, but that is a for sure way to get those proper points. So in this case, we have x to the 4th, so therefore we should have 5 coefficients in there. X to the 4th is 1, x cubed is 2, x squared, there's no x squared term in there, so we have to have 0, negative 5, and 1. Okay, so again, you would have to do that for all 5 points. I'm not going to walk through it on this video, but again, make sure that you are ending here. It's all in between there that matters. So that is rough sketches of polynomials and end behavior. If you have questions, make sure you are asking those. As for homework, 6.2b assignment, okay, use what you know about end behavior to match the polynomial functions with the graph, and then end behavior. Do not worry about this. Okay, again, when you are writing those, it's as x approaches infinity, f of x is approaching something. As x approaches negative infinity, f of x is approaching something. You will have to write that every single time. This part will not be given to you, so make sure you get that part memorized. Okay, better way to do that is just have a good understanding of what it is saying. All right, so other than that, let's make sure we do our homework and have a good day.